Vamos a iniciar con el bloque titulado de los tweets a los resultados, cómo obtener, minar y analizar los datos de Twitter, a cargo del doctor Derek Tut. Graduado de la Universidad de Rice en Houston, Texas, en el 2013 obtiene el bachillerato en Ciencias de la Informática, y en el 2006 obtiene una maestría en la misma universidad. Pero en el 2009 obtiene su doctorado en informática. Trabaja como profesor asistente en Magritte University desde el 2009. Es cofundador de la realidad avanzada. Sus intereses de investigación son informática social, las ciencias de las redes y el procesamiento del lenguaje. Posee cerca de 40 publicaciones entre artículos científicos, capítulos en libros y publicaciones revisadas por expertos. Además ha participado en al menos 20 conferencias, 8 tutoriales técnicos y ha sido participante de más de 40 charlas y paneles.
Thank you very much for the opportunity to be here. My apologies for not presenting in Spanish. I had 3 years of Spanish in high school, and it would not be enough for presenting this material. In fact, I grew up in Texas, where Spanish is very common, everybody learns it, and then I moved to Montreal in Canada, where French is very common, and French has completely replaced everything all the Spanish that I know. In fact, I've tried to use it here, and all I say is French. So today I want to talk about a topic that I think is very related and very important to the question of data mining and statistics, but that I consider complementary to, I think, the core questions that a statistics department would be asking. And for that reason, I think that it's very important to have an awareness of how data mining is done on any particular data set, and we'll be talking about Twitter today. Throughout the presentation, I'd like to invite you to ask questions whenever you have them. It helps me understand what's particularly relevant or where I should be spending more time. So please ask questions and give me feedback. Some of the examples that I'll be using, I have put a file that you're welcome to download. It involves having Python and Unix installed, so you don't necessarily need to follow along, but at the end of the lecture, you'll have the materials so that you can go and do some of what I'm showing you on your own. So 3 years ago, I was sitting in my home office at about midnight, answering some emails, doing some work, and my entire apartment started shaking. And it was an earthquake. Montreal gets these. But the first thought that I had was, whatever my downstairs neighbor is doing, he had better stop before he wakes my kids up. But the shaking continued, and I finally realized that my downstairs neighbor, short of getting a bulldozer, would not be able to shake my entire house. I realized maybe this is something else. Maybe it's an earthquake. And so I thought, well, I'd better get some information on this. So I opened up Google, type in earthquake Montreal, nothing comes up. And I think, how am I supposed to get information about something that's just happened? And so I sit there for a few minutes, and then it occurs to me, I'm a researcher in social media. I should check social media. I should look at Twitter. So I go up Twitter, search earthquake Montreal, and sure enough, over 100 tweets come up, people talking about it, people posting links to previous earthquake accounts in the news. And to me, though I didn't appreciate it at the moment, that to me is a perfect example of why social media is such an important and valuable resource to us today. And it's anecdotal evidence of why social media is so valuable to us as researchers. So fundamentally, the reason that we use Twitter or any other form of social media. The reason that we choose to research it primarily is because humans are very difficult to observe. They're very difficult to get information about. So the traditional approach to getting information about people is surveying them. Design a survey, you go out, you ask people questions, and it's a fantastic way of getting information about people. You get to decide what questions they answer, you get to determine how they answer. Is it multiple choice? Do they get to write something? How do you want the material? And you know who you're talking to. It's very useful. However, surveys have a number of problems. One would be, what if I asked you what you ate for lunch 3 days ago? It's really hard for a lot of these survey questions, it's really hard to answer the question accurately if it's about historical context. And then we have the additional problem of sort of the human-to-human interaction bias. And this arises very often when trying to get information from people about eating behavior, about exercise behavior, about sexual behavior. People are not going to answer necessarily honestly, they'll answer the way that they think they should answer. You know, how many hamburgers did you eat last week? Oh, 1, maybe 0. I had 4. So the problem is that we always want to actually answer a bit differently because we have this sense of human judgment. So we'd like to be able to get away from this. And also, surveys are just very expensive. They're slow and they're expensive. And so if there were another way to get information about people, that would be very valuable, even if it was a noisy way of getting information about people. And so enter Twitter. Twitter, as we're going to see, is basically free to obtain. You can get it for the price of an internet connection and a computer. It's fast. And as I talked about with the earthquake example, it's real time. People are posting things in real time. We can get that information in real time, but also, very important, people produce that content in the moment they experience something. So if I'm angry at Starbucks, if somebody spills their coffee on me at Starbucks, I tweet about it right now. I say, somebody dumped coffee on my sneakers at Starbucks. And you hear about that right now. And so if you're interested in Starbucks experience, you don't have to go ask people, what is your general experience of Starbucks? And then I have to say, it's pretty good, forgetting about the fact that someone dumped coffee on me the other day. You can actually find out exactly what my experience is like. Now, it has problems. It has serious problems. Twitter does. You have no idea who you're talking to. It's a fair guess that you're talking to a 14-year-old girl. But in general, you have no idea who you're talking to. You can't really control who you're talking to, so you can't segment the population easily. And you also don't really have an idea of the kind of context that the person is in. In addition, you're not getting answers to specific questions. You're getting this free text. But I'm going to make the argument, and I believe that a lot of research and investment in social media makes the argument that there's still a lot of good that can come out of Twitter, out of studies of Twitter, out of studies of social media. And in particular, I would make the argument that Twitter is not, that studies of Twitter and studies of social media are not designed to replace surveys. They're designed to make surveys better. And they should be used, social media data mining should be used to help design surveys that get you the information that you want. Often the problem that we run into with surveys is you run a survey and you realize that you didn't ask the right question. And so how do we make sure that we're asking the right questions? How do we make sure that we're trying to get the answers the way that we want them? Well, we can look for what people are already telling us. And social media data mining can actually allow us to do that. Now, there's a lot of evidence that suggests that social media actually does reveal human behaviors. Because one possible criticism is you could say, well, maybe it reveals human behavior, but it's so noisy. I mean, everybody's talking about who knows what. Maybe we actually don't learn anything from it. But there's tons of publications and there's tons of research that suggests that it is possible to actually get real signal about what people are doing in the real world through Twitter. through other forms of social media. And you can study some really difficult to access phenomena. I mean, like this user behavior online study that just recently came out on Porn 2.0. Like, that's not Twitter, but it's a relevant question about sort of sexual behavior. How else would you get that information except by actually mining online data? And so it actually enables research that would be almost impossible to conduct by other means. Now, I use the term social media, and we will be talking primarily about Twitter. But I want to take a moment and really connect what we're going to be talking about into the ideas behind this particular workshop, which is big data and statistics. And so to do that, I want to talk about what social media is, how it relates to big data, and how it relates to you as statisticians. Or you may not be statisticians, but how it relates to sort of the questions posed by statistics. To begin with, social media is a very broad category. I think there's a lot of misunderstanding in terms of what it is. People are lumping all kinds of stuff into social media. My definition of social media is it's any platform where the content that I see as a user is somehow influenced by the behavior of other users on the platform. And so, just to go through some of these. So Reddit, for those of you who know Reddit is a definitively social form of social media. People can upvote and downvote content. People can contribute content. So what I see, what hits my feed, is definitely what people have put up there and what they're voting on. Twitter, I directly follow people. What I see is what other people post. That's social media. Facebook, the same thing. News sites. So news sites, I think we would not consider news sites traditionally social media, but there are aspects of them that actually are social media from the standpoint that they may actually allow viewing behavior to drive what's actually moved up and down, what's actually presented to users and not presented to users. The comments section of news articles is certainly social media. I can actually see user behavior there. And then Amazon. Amazon is kind of a playful example. It's not really social media by sort of in a traditional sense, but the products that you're presented with when you actually access the site, it says here are your recommended sets of things. And if your significant other has been on there, then you see totally wrong recommendations. I'm forever seeing like books on knitting and things like that, which is when I know my wife has been looking for things on Amazon. But it's trying to make recommendations about it's trying to make recommendations for you based on what other people have done. And then, of course, there's also the comments section, the reviews, where you can rate things as being helpful, vote for them. You can do a lot of these different things. That's social media as well. So anyway, social media is much bigger than we often think it is. Now, social informatics is even bigger than social media. So social informatics, which is, I consider myself a computational social informatician. I'm a computer scientist, but I work on asking questions about social behavior. And so I work a lot with social media, but I consider myself to work more broadly on questions of social informatics, where we're trying to use quantitative methods, or sometimes develop new quantitative methods, either computational ones or statistical ones, that allow us to speak about human behavior in large data sets. Now, what does large data sets mean? This brings us to the question of big data. Some people will say, oh, it's a data set that's large enough to be representative of things. It's a data set that's at least this many petabytes. My definition of big data is just like, when you look at data and you feel scared about the prospect of having to actually go through it yourself, that's big data. It's like, the big bully on the playground. How big does he have to be? Just bigger than you. It's easy. So big data to me is really the question of when you're presented with more data than you want to go through by hand, or than you can hold in your head, that's big data. We need computational techniques, we need statistics, we need natural language processing, we need all of these tools all of a sudden. Now, one of the things that in discussion with some of the organizers of the workshop, I had learned was that this is really part of developing a program around big data. And so I would like to make an argument or make several compelling cases for why investing in social informatics as a particular direction for big data research is a really good direction, particularly for a new program. And to me, this is as relevant to those of you who are faculty members and students. First off, social media is a big topic that has a lot of relevance in a lot of places. It's very popular, it's very sexy, and so it's going to be very easy to actually attract students and staff to working on problems around this. Second is, it has very quick wins. So if you work with something like Twitter or Reddit, as I'm going to show you, you can literally get a data set in 30 minutes. You can get the data set that you want to ask a particular meaningful question in between 30 minutes and a day. And that's answering a question that you could publish a paper on. So if you're looking to actually build competency in an area that's actually going to allow you to quickly generate results that are relevant, that people find interesting, and that in particular are fundable, social informatics is a very good place to look. And insofar as we have to actually position this, and I think about this too up in Canada, I mean, no matter where you are, we have to think about funding, we have to think about these kinds of logistics. Social informatics is very practical. You can ask questions about the state of roads, people's satisfaction with healthcare, what kind of restaurants people like on campus. You can ask very pragmatic questions, and that's very important because if you're going to actually go and try to talk to governments for funding, very often when they have limited funding to allocate, they would be much more interested in things that they're going to be able to point at and say, this delivered results, that we learned something that we could actually change policy for. And then finally, social informatics is a very accessible discipline. So as opposed to doing sort of theoretical work, which is, of course, very, very important, working in social informatics, there's a lot of emphasis that's placed on using fairly basic computational and statistical techniques that can generate very, very useful and very profound results. And the wonderful thing about this is that these kinds of early investigations can also motivate bigger theoretical and technical investigations. So I think that they often provide very nice starting points for this kind of research. Okay, so that's my spiel about social informatics. Now, to position this talk, this is my sense for what a social informatics workflow looks like. This is what happens when you work with Twitter, Reddit, Facebook, even biological data, really. So you define your question. And by defining question, I don't just mean you're sitting there in the shower, you're standing there in the shower, and like a question hits you, and then you're like, perfect, I'll go do research. No, you really think about the question, and you lay it out very precisely. Everything you want to measure, the kind of outcome that you want quantitatively, you have your question. That tells you the kind of data that you need. Now you go and get your raw data from wherever it is that you need to grab it. From that data you're not going to be able to work with immediately. As we're going to see, we're going to spend a lot of time making our data something that we can use. So then you extract the features that are relevant to the problem that you want to approach, the question you want to ask. So you have to extract this higher level data from the raw stuff that you get. Sometimes that's very easy. Sometimes it's actually quite difficult. Sometimes that's a research problem in and of itself, which is why I put up this develop extraction methods. As a computer scientist, I think a lot about how we develop extraction methods. You may get text. What if you want to know, what if you need to get all the nouns that are in the text for whatever reason? Well, you're going to have to do something fairly sophisticated because just using a dictionary to go find all your nouns is going to miss all kinds of things. So you need natural language processing in order to do that. There's lots of complexity that can arise in extraction. And then once you have your extracted features, I have a laser pointer. Once you have extracted features, we analyze the features. And of course, in order to actually do this analysis, we may need new analytical tools. And I would say, in large part, this is where the contributions of statistics have been most profound in the area of big data and social informatics. And that is, we've already mined the data. We already have the features that we're interested in looking at. How do we say something? How do we say and make meaningful assertions about what it is? How do we go from all these words and say something about the distribution of topics that people are talking about? How do we actually model this higher level structure? And so there's a lot of important statistical work that has to happen there. We analyze the features, and then typically what happens is you completely don't get the results that you needed. And so you have to go back and you have to collect new raw data, or maybe just extract more relevant features. And so you enter this very painful and tedious loop, which eventually you exit out of, and then you publish your revolutionary findings. And then you're done, and then you move on to your next project. We would like to spend most of our time right here. This is where we'd like to spend our time. Unfortunately, that's not what happens. As a data scientist, most people think that we spend our time like with these wands, like just waving them around, transforming all kinds of things amazingly. Most of the time, at least for me, I spend time sitting here sort of helplessly pounding at the computer trying to get it to do something even remotely close to what I actually want it to do. And so where we usually spend a lot of our time is right here. How do we get the data that we need? How do we get the features that we need? Those end up being very non-trivial. And actually, that's what I'm going to spend time talking about today. I want to help you appreciate, dealing with a particular kind of data set, Twitter, what is it that's actually, what are the nuts and bolts of how do we do this? How do we go from getting data to getting the kind of features that would allow us to do the analysis? And then we get to the really fancy, fun stuff, which you guys talk about another time. So if we want to do this, what are the kind of tools that we're going to need? So in terms of disciplinary background, having computer science training, having statistics training is very valuable. And this doesn't mean that you have to have a major, it just means you have to know about the techniques. And you have to have more than passing knowledge of these techniques. And the theoretical constructs. In terms of technical skills, and everybody's very opinionated on this, so I'm giving you my opinion on this, but talk to somebody else, they'll give you a different set of tools. But my personal sort of pantheon of tools is Python, R, and Unix command line. And probably the hierarchy ranked order, these are not in order, it would go Unix command line, Python, R. And this is primarily for dealing with data collection and data manipulation. Python is an interpreted general purpose programming language that allows you to write at a very high level. And I'm going to show you, we're going to do some of our analysis in Python. And Unix command line, it's just where computational wizardry has always been done. And it has amazingly powerful tools. And if you really do want to work in this area, I cannot underscore enough how important it is to go learn and develop a familiarity with using Unix. And I'm going to demonstrate a variety of things that we can do with the Unix command line as well. Now, why do we have to learn this? I mean, as statisticians, I know that the statistics typically says all you need is R, that'll be fine, you're all set. But suppose this is what you're supposed to turn into data. Suppose what you're trying to model is how often men versus women exercise. And this is your raw data. Your raw data isn't even numbers yet. Your raw data is this web page that's called Photocracy, and there's 5 million of these pages out there that you need to somehow turn into data because the data's there, right? This person just went for a run. This person just went walking. This person just went running. How are you going to turn that into the numbers that you need? Well, you're going to have to do some pretty fancy data collection. And R is simply not designed for that purpose. I mean, can you do it in R? Yes, I've seen it done in R. You can do it in R. But that would kind of be like building a house with a carrot rather than a hammer. They're not designed for that purpose. So I would highly recommend that you look at Unix and you look at Python as supplements, as complementary tools in your toolbox. And hopefully you'll see some examples of why they're so powerful. Okay, so what we're going to talk about in the rest of this workshop is, first we're going to talk about sort of a detailed dive into what the Twitter platform is. And hopefully we'll get to see a lot of these sort of big picture ideas that I just talked about. We're going to talk about what the Twitter platform is. We'll talk about how to interact with the Twitter API. Twitter is quite nice in that it's given an API to interact with it rather than having to scrape the content off of Photocracy. We did a study on that website, by the way, on Photocracy. It's published. It took the better part of 2.5 months to figure out how to get all the data out of that website because they don't have an API. There's no nice programmatic way to do this. So we had to actually, I'm talking about this thing right here, we had to figure out a way of actually scraping all the content off of this thing. It was tedious. Twitter is much nicer. It has an API, and we'll talk about it. We'll talk about ways that you store Twitter and how you interact with that data. And then we'll talk about how we analyze that data that we've downloaded. And I'm going to talk about some of the more sort of fundamental basic techniques that you'll see in the literature all over. And then I'll highlight a couple sort of things that would be good to look at and learn. What we're not going to talk about are maybe some of the things that as statisticians you might be more familiar with, which would be questions about sampling, about experiment design, about hypothesis testing, and these sorts of things. These are important questions as well, but what I really want to focus on is how we get and work with Twitter data, separate from the questions of sort of good experiment design and result validation. All right, so this lecture is in 3 pieces. We're going to talk about sort of introduction and concepts, then we'll talk about how we get data, and then we'll talk about analyzing it. So just to start at the very fundamentals, and we'll move past this very quickly. So the way that we're going to get our data from Twitter involves accessing content over the internet. Now, how many of you have used Twitter or seen Twitter some way? Okay, good. Well, so for those of you who have used Twitter in some form, either your phone or a web browser, this is what it looks like. You've got Firefox or Chrome or your web browser here, and it's basically talking to this Twitter server over the internet. That's how you see web pages. All we're going to do in order to do the analysis that we want to do, in order to get data, is we're going to swap out that web browser for, in this case, Python code. But there are other libraries for getting Python data, and there's Ruby libraries and so forth. What we're going to swap out for is a programming language that's going to go and grab that content. But it's going to be basically the same interactions. It's going to send content to Twitter, and Twitter will send information back. Okay, so what is Twitter? So Twitter is a microblogging platform. That means that people can make very small posts to their account. They're 140 characters or less. There are a number of salient sort of things that people can put in their tweets. You can put in hashtags, which are intended to capture topics, the topic of that tweet. So for instance, I know that there's a hashtag for this workshop. So if you were to tweet about this workshop, you could use that hashtag in order to indicate that this tweet was about that. A little bit later on, we're going to do some analysis on tweets that all use the hashtag big data. Just because that's sort of the topic that we're talking about here, and so that brings in all tweets that are relevant to this topic. Interestingly enough, I don't know how many of you have observed this yourselves, but I have a number of younger cousins in the teenage range, and they have actually adopted hashtags, this symbol, for actual speaking. So they don't air quote anymore. They don't do this. It's like they'll say something like, well, I'm going to do this all wrong because I'm too old, but it would be something like, oh man, that is so cool. I'm like, what? You can't hashtag when you're talking? It's those kinds of things that concern me, that in a couple of years I won't know how social media works at all. So anyway, hashtags. There's also mentions. So if you put an @ symbol at the beginning of a word, that means that you're referencing a Twitter user. So for instance, my Twitter handle is Derek Ruths. So if you wanted to mention me favorably, you could write @Derek Ruths. And then you could write something. And what that would do is that would allow anybody who interacts with that, first it would signal it to as you're talking about a person. Twitter will actually link that to another person, so a person can click on that in the interface. And it also notifies me that you've talked about me. It will say you were mentioned in this case. And so there's a lot of interaction that's created around these structured mentions. The other thing to mention is, the other thing to comment on is that URLs are typically shortened, which creates all kinds of pain when you're trying to do research. So, for instance, if I was to paste in a long URL, Twitter has its own URL shortener that'll shorten it to t.co/ and then some random set of characters. The problem is that if you actually want to look at, for instance, how often people link to YouTube, everything's shortened. And so it can be a real pain to try to figure out how often people are actually referencing YouTube or BBC or some other website because these things are being masked. But it's something to be aware of, and it's ubiquitous. It's everywhere. Okay, so here's some examples of some tweets. We got a nice, meaningful one there. Happy birthday to this person. 21 until 5 followers. Just want to pound follow me. All these touchscreen phones, yeah, they stay cracking. Yeah, I get a flip phone. So a lot of tweets don't make a whole lot of sense. Fortunately, there's a lot of them, so we can just ignore the garbage. But Twitter is full of stuff that is not worth looking at or very interesting. So to give you a sense for sort of what you can do with Twitter data, with just a little bit of analysis, a couple of years ago, we decided in my lab, we were going to look at what people were wishing for Christmas. Because one of the things that people do is right around Christmas time, starting in October, they'll start saying, I want blank for Christmas, or for Christmas I want blank. So I thought, this can be great. We'll find out what... My big plan, to be totally honest, was I was going to mine these wishes, and then I was going to figure out what was going to be selling. Then I was going to figure out how to invest in it, and I was just going to make a bazillion dollars. And it was going to be great. Maybe start a hedge fund. I'm still here. So that didn't turn out as well as I had hoped. But the reason is interesting. So we did a very simple analysis. We looked at we basically looked for all tweets. I said, I want blank for Christmas, or for Christmas I want blank, or all I want for Christmas is blank. And it gets you wishes. It definitively gets you wishes. Now this is now 3 or 4 years ago now. So does anybody want to guess what the top wish was? Sorry? Happiness. All right, happiness. That's optimistic. All right, well, we'll take a look. All right, so here we go. So the top wish for Christmas was Justin Bieber. At this point, I really started to question the research direction I had chosen. And by the way, this is all scaled. This is Justin Bieber really did win by that much. And by the way, this is not we didn't normalize. This is not like Justin Bieber music or an album by Justin Bieber. These people just wishing for Justin Bieber for Christmas. And then we get things like hippo. Does anybody know why hippo's up there? This is it was definitely like an Englishism. So it's a Christmas song. It's an English Christmas song. I want a hippopotamus for Christmas. That's how it goes. And my two front teeth. That's also a Christmas song. All I want for Christmas is my two front teeth. New Year's Day is also, so there's, you can't just take this and invest in the stock market, unfortunately. But there are some interesting trends in here which I think are worth pointing out. I mean, once you dig through the sort of noise at the top, you do get some interesting things. So you get people talking about sort of like non-tangible things, right? So they talk about, for you to follow me. They talk about money and jobs. Boyfriend, girlfriend, I'm not entirely sure why they're at opposite ends of the list. I don't know why boyfriend is so much higher. I'll let you sort of speculate on that. An interesting one is fantastic t-shirt. So on fantastic t-shirt, people were wishing for a fantastic t-shirt everywhere. And I was thinking, why are people wishing for this fantastic t-shirt? And then I come to find out that there is a company that has said if you tweet that you want a fantastic t-shirt, you'll be entered in a contest to get a t-shirt. And so, in any way, the point behind this is to show you that analyzing Twitter data requires a lot of patience and a lot of time in order to really sort through what's in it. On the upside, we did determine that you can predict relative unit sales of things like video games using this. So actually, once you call out all the noise, you can actually predict Xbox versus PlayStation versus Wii sales using basically wishes on Twitter. Okay, so that's tweets. But Twitter is actually more than just tweets. It's also a social platform. So the content I generate has to go to somebody. So on Twitter, people can follow one another. If I'm following you, then I'm your follower, and your friends are the people that that you've chosen to follow. So if I'm following you, you're my friend, I'm your follower. And so there's like a micro social network that we have here. Here's this person, they have a bunch of friends, they have a bunch of followers, and of course these can often overlap. So this is called a reciprocal tie, because these people are mutually following one another. And in general, that's often considered a fairly strong signal of some kind of actual relationship that exists. Because you're not going to, like, as much as I'd like it, President Obama, Lady Gaga, they don't follow me, despite the fact that I may follow them. And so these reciprocal ties generally mean that you're getting attention from the other person. And then once we have the social network, then we can actually start talking about information propagation. So we have somebody up here, one of my friends tweets something informative like, check it out. I get that and I say, wow, that's a great tweet, I need to share that. So I retweet it. There's a convention on Twitter. The retweet goes out to all of my followers. And this is one of the major mechanisms by which information is propagated on Twitter. So we have retweets. And retweets can be a very useful way of thinking about the social graph. And we'll talk about that towards the end of this lecture. Okay, so given this setup, there's a whole bunch of stuff that we can look at in terms of Twitter-based research. We can look at content-based stuff only, so we can look at topics that are trending. There's been work on predicting elections based upon the number of times a politician is mentioned, how popular movies are based on how often they're mentioned. That's content analysis. You can also look at structure-based analysis, or primarily structure-based analysis. That's where you look at the social network. So you might be interested in what's a community structure? How are people grouping themselves? How many friends do people tend to have? How well connected are people? Who's the most important person in terms of follower-followee relationships? So these are the kinds of things we can ask just about the network. The most interesting work, I think, happens when you combine structure with content, because then you can start thinking about diffusion of information. You can even revisit some of these ideas, trending topics, but better understand the context within which they're trending, or why they're trending, because you can start to understand that they're actually trending because there is a community that's making them popular. But without actually looking at the network, it's very hard to know what the basis for popularity is. Okay, so that's sort of a big sketch of how Twitter works and how we can think about Twitter. I want to now talk about Twitter architecture, which is going to be our way of getting into talking about the actual API. So this is sort of the technical guts of Twitter. So there's basically two objects in Twitter that you might be interested in. There's the user and there's the tweet that they generate, and both of these have unique identifiers, as in really long numbers that identify them. And so when you want to uniquely talk about a user or uniquely talk about a tweet, you can specify that user ID or tweet ID. And that comes across in the metadata when you collect them, which we'll see. There are there's three ways of getting Twitter data. There's the REST API, which means that I ask Twitter for a specific piece of information. I say, give me the information give me all the tweets that user 12345 6 has generated. Or I can query and I can say, give me the information on this tweet, on tweet 192345573, blah, 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 and it will return it to me. That's REST. So I have to actually call Twitter in order to get that. There's the streaming API, which is where you don't ask Twitter explicitly for each thing it gives you. Instead, you connect up, you give Twitter some idea of what you're looking for, like a filter definition, a Boolean statement, and then it just starts throwing tweets at you. It just dumps them continuously down. They're streaming to your computer. This is by all means the most popular way, and I would argue the most effective way of getting information. If there's any way to structure your research question so you can use the streaming API, do it. The third technique, which I do not advocate but is used, is scraping Twitter. So both of these we will talk about, but both of these are rate limited, which means that Twitter is only going to give you so much because if everybody could take as much as they wanted, then everybody could have their data, and also it would really hurt the performance of their servers. So they rate limit this for a good reason. They do not rate limit web page accesses. So for instance, you could pull up Twitter web pages over and over and over and over and over again, and as long as you were not being totally naive about just doing it from one IP address over and over and over and over and over again, Twitter would not know that you were doing it, and you could scrape as many Twitter pages as you wanted. So that is your third option, just to be totally comprehensive. It's your third option in terms of approaching it. The issue with scraping is, one, you're technically not allowed to do it, and two, you don't get metadata. You don't get all the information that comes along with a tweet or a user. And this is stuff that you may not have seen before. We're going to see a lot of it, but there's a lot of information that comes along with the tweet when I download it. For instance, when I download a tweet, I actually get information about the platform it was generated on. It's not shown to you on your phone, it's not shown to you on your web browser, but it's there. But you don't get it if you log in, if you access it through web scraping. So talking a bit for a moment about streaming, there are 4 different levels of streaming access. The full-blown access, so Twitter does offer a full stream of every public tweet that is generated. That's the fire hose. That is, frankly, more information than I think any research group could probably handle. It's over a terabyte of data a day. And simply actually keeping your connection, getting your computer to be fast enough at storing data is actually an engineering problem when you're dealing with the fire hose. So it also costs a fantastic amount of money, so I wouldn't worry about it. You can also get a subsample, a 10% subsample called the garden hose. Typically you have to pay for this, although in some rare circumstances, academics have been able to get free access to it. And this gives you 10%, and it's a 10% random sample. And then finally, the spritzer is totally free. As long as you have a Twitter account, you can connect up, and the spritzer will feed you 1% of all tweets. Now, depending upon how you run your query, 1% can actually give you complete coverage, or near complete coverage of what you want to search for. And we'll talk about that in a bit more detail. So actually, the spritzer can often be plenty. And as I said, always try to use the streaming data. So, let me switch over for a moment and just show you, give you a sense for what you, well, actually, let me do that. Let me do that in a minute. We'll dive into our next topic, which is how we actually get the Twitter data. Before I jump into that, are there any questions? Yes? What's that? What is an API? API is short for Application Programmer Interface, which probably doesn't help at all. So an API is it is a defined way of getting information from some computational resource. So for example, on Twitter, as we'll see, on Twitter, let's use a more playful API. So I can implement an API as a human being. I can implement an API, and that API would be something like, you have to say, if you want to get information about the last 3 people that I met, you come up and you say, hello, 3 people. You have to say those words. And then my response would be the last name, first name of each person. So I'd say Ruth's Justin, Ruth's, Matala, my wife's name, and then, Smith, John. So you'd have a guaranteed way of knowing exactly what I was giving to you. That's different than web scraping, where web scraping, you don't know what you're getting. You download the web page and who knows what it actually contains. It could be HTML content, it could be XML, it could be just random text. The idea behind an API is it's structured. So when you come up and you say, hello, 3 people, you know that that's going to generate a response, and you know exactly how to parse that response. You say, when Derek responds, he's going to say last name, first name, last name, first name, last name, first name. Done. Much easier to actually parse this information and get it into a format that we can work with. If you're web scraping, you're just getting web pages. And one of the biggest problems with web pages isn't that they're unstructured, it's that they can change. So for instance, if you download web pages from CNN last week, and you download more articles from CNN this week, the formats might be totally different. They might have changed the tags they're using, they might have changed the actual organization of the website, no guarantees. So an API is very, very valuable. Other questions? Okay. So, speaking of APIs, let's talk about getting Twitter data. So, as I mentioned, we have two different options in terms of how we get data. There's the REST API, and there's the streaming API. The REST API involves these queries. So here you are. Here's the server, the Twitter server. Rendering here. And then here's Twitter's sort of back end. So you connect to Twitter's server, and you make a request. You say, give me the last 500 tweets of this user. That's passed back to Twitter's database. Twitter pulls out the last 500. It feeds them back, and then it responds and it sends it back. Now, this is I took this from a user who's writing a web page, but this is basically the same way that it works for a web service. You write a little program, it issues a request, it eventually gets a request back. In the streaming case, what happens is you basically make a request, and then you get this continuous feed of content back. So you don't have to keep requesting, get a response, request, get a response. You just ask, and then you just leave this open. And this will stay open for hours, for days. It'll just keep giving you content. If you want to get into the details, this is where you go for all the details on these APIs. We're going to talk through them. This is where you go for all the really sort of nitty-gritty details. Now, regardless of what API you use, you're going to get information back in JSON format. How many of you are familiar with, have seen JSON? Show of hands. Okay, good. Well, then this will be useful. So JSON has a habit of looking horrific, like a terrible format, but it's actually very, very useful. So this right here is a tweet. And actually, I've cut out a lot of the stuff, but it basically looks exactly like this. The important thing about a JSON object is that it is structured. Along the lines of sort of what I had in my answer to the question about the API, it's structured, so you know exactly how it's going to look. So there's a couple concepts that we have to talk about here in order to make sense out of the JSON object. The first is the different types of things that can appear in a JSON object. And by that I don't mean the different pieces of content that's in a tweet. We'll talk about that too. This is about the different kinds of information that can be there. And we can see a number of them here, right? So there's things like words, right? And the things in quotes are strings. There's numbers. There's booleans, true and false. Is there anything else? Oh, well, and then there's dictionaries. And that's these curly braces. So a dictionary is worth talking about for a moment. So a dictionary, exactly the same as a dictionary in language. A dictionary is an object that contains information that you can look up by a particular entry. So a dictionary has a key and a value. So in a linguistic dictionary, the key is the word you're looking up, and the value is the definition of that word. In a translation guide dictionary, the key would be the word in your language, and the value would be the word in the other language, or the words in the other language that you're looking for. And the value of a dictionary is that it may not feel fast when you use it as a human being, but it's organized. It's organized in this fantastic way. So if I want to know, I don't know, what the definition, what the Spanish word is for, to find, I would go and I'd say find, F. So I'd go to F, I'd go down, I'd find, and I'd say, buscar. And I'd say, oh, excellent, there's the word that I need to use. And so it gives me a fast way of accessing information. And that's exactly the way that this is going to work. It doesn't look like a dictionary, but we can tease it apart, and we can see that in this dictionary there are keys, values. Key, value. Key, value. So every key is going to be a string, and values can be anything. So here the value is a boolean. Here the value of text is a string. Here the value of this string, the value for this key, it looks like a date. It looks like a date, and indeed it is a date, but that's not the type of thing it is. What is it? It's a string. It's a string. JSON doesn't give us ways of actually writing dates explicitly, so it's a string. Here, this is a string key, as it should be, what is this? What type of object do you have here as the value? It's another dictionary. So we can actually have dictionaries within dictionaries within dictionaries. This dictionary contains key value, string, key. Now here's an interesting value. This is a list that contains numbers. So in any case, that's how JSON is structured. It looks messy, but from a programmatic perspective, it's perfect. Because we can index in. I can say, load this up, and we'll do this. So we can say, load this up, and give me this information. Give me the value associated with text. and I'll get the content of the tweet. And actually I was going to show that, so. All right, so welcome to my Unix command line. There we go. So I'm doing all this offline, by the way. Demos are frightening when I do them on the internet, so I'm not using the internet. So I downloaded everything that I already need. Crucially, in this directory that I'm in, we have a file called Big Data. So I just went last night. I went and downloaded basically 2,000 tweets that contain the word Big Data somewhere. So and we can see that. I'm just going to print some of it out. So this is the contents of that file. And I don't expect you to make any sense out of it, but you can see that it's JSON objects. You see on those curly braces, there's the end of the dictionary. We've got key value, key value, key value. It's a JSON, these are JSON objects. So if we actually want to work with this, if we want to go work with this, let's start at the command line. So we can extract content using a command line function. How many of you have used the command line anyway? Okay. 30-second crash course on the command line. Command line is a new way for those of you who have not seen it before, it is a new way of talking to the computer. Whenever you see hackers in movies, they're using this. So, learn it just to be like the hackers. It is a very powerful way of communicating with the computer because you get to tell it precisely what you want. No clicking, none of this involved. You literally talk to it. So, for instance, the command that I issued before, head big data, head is the command. That's what I'm telling the computer to do. Head means print out the top of this file. And bigdata.json is the file that I wanted to print out. And so it printed it all out. That's those 10 lines from the file that I gathered. If I wanted to slightly modify that, I could say if I only wanted it to print out one line, let's say, I could do -1. So that's an argument that I'm giving to head. So now I'm modifying head's behavior. Head is still the action, the command, head. But now I only want to print out 1. So -n means this is the number of lines to print out, 1. Then I get a big data. Well, you can't really tell that it made a difference, but it did, and it turned out 1. Actually, let's pick a different file. Let's see. Okay, so there's the top 10 lines of the file sentiment.py, which we'll be looking at later. And there I've modified the performance of head so that it only prints out 1, and sure enough what we see is that the first line, second line, third line, fourth line, fifth line, there's the first line. So, print out 1. Okay, so all of the stuff we're going to do on the command line basically revolves around writing a command, what we want the program to do, or what we want the computer to do for us, and then giving it some information that it needs to perform it. So it's no different than giving people commands, although that's typically less polite. Right? So you could say, like, dance, but issuing the command dance needs some parameters. How do you want the person to dance? Like dance, the chicken dance. There's your argument. And then the person has enough information to actually go and do the appropriate dance. Sort of a weird example. Okay, so if we wanted to parse the content here, we have a command line argument called JQ, which is JavaScript query, stands for JavaScript query. And we can tell this command to look for particular fields, dictionary elements, in a JSON object. And so, for example, there we go. We might be interested in looking at text. So text The field is, the entry is text. That's the key value. So we'd like to look for text. I think I can do this. Let's check. Yes, it worked. Okay. So what I've done is JQ, I usually write this command a little differently, but JQ is the command. .text is basically the entry in each object, each JSON object that we encounter. And this is the file that it's going to walk through. It's just going to walk through, pull out each JSON object one at a time, look for .text, look for text in it, print it out. All right. Again, this is a lot of tweets, so maybe we only want to print out a couple of them. So what I'm going to introduce you to, like you guys are getting a really fast, but like right to the heart introduction to command line. I'm going to introduce something called a pipe. So a pipe allows me to take the output of one command and make it the input of another command. So the output of this was all this stuff that printed out. But what I would like to do is, I don't want all of this, I just want to look at the first 10 lines. You know a command for that. What's the command? Head. So we have head. So instead of printing this out to the screen, we're going to pipe it into head. Now, rather than put a file name here, if I leave it blank, head says, okay, well, I'll just look for something being given to me directly. So now what we did is we get the top 10 things. And that allowed us to actually pull the content out of big data using just .text. Now, just reflect for a moment how easy that was. Now that you're seeing how to do this, reflect on how much easier that is than having some unstructured scrape of Twitter data. Like, this is about as easy as you could make it when you really think about it, like for getting all this content. By the way, just to really close the loop, if we only wanted to see two of those lines, we could do -n2, right? And that's just going to print out 2 tweets. We're going to build on some of this, so this is why I'm sort of showing this stuff incrementally. So one of the things that's kind of irritating is that there are these quotes on here, which serve no purpose, because they're supposed to be quoted in JSON, so it's spitting it back in JSON format, but it's not particularly useful for me because I already know that it's strings. So I'm going to tell JQ to take off the quotes when it prints this stuff out. And so I can give it the -r argument. It takes no arguments. Unlike -n2, -n needs something after it. -r, it's called a flag. It basically says, just do it, just print this out in raw form. So .text is not the argument for .r. .text lives by itself. So now if I run that, now I've gotten rid of my quotes. But now you can begin to see, and we're going to start sort of building our way up, now you can begin to see how using the command line, the Unix command line, you can actually build quite quickly a data set that you could then do higher level analysis on. Okay, so we'll come back to that in a moment. Let's go through and talk in a bit more detail about how these APIs work. So in order to access Twitter, it used to not be like this, but nowadays Twitter requires you to authenticate yourself to them before you call any API. So by authenticate, what I mean, you need to log in, so they can actually associate what you're asking for with your account. And so login is always so friendly on the web because you enter your username and password. That's not how it works on the web or in APIs. You have to use something called OAuth. And OAuth basically is I'm not going to go through the details of it because I don't have the internet, or I didn't assume the internet right now, but, well, we'll take a look. But the important point is that what OAuth does is it makes it so that your script doesn't need to hang under a password, which is actually a really good thing. You generally don't want to just have your password sitting around in various scripts that you're running. Instead, what you do is OAuth allows you to create a token for the specific script you're writing. So you can say, this is my research, this is my research app. And it gets all these keys that are associated with it. And what you do is you specify those keys when you access the Twitter API. I want to say that I have... Oh, I think I'm going to go into more detail later. Okay, so let's assume that you've logged in. Now we would like to actually be able to query for particular information. And this is the REST API. So this is... for reasons I'll explain in a minute, this is the slower way of accessing Twitter information. You can't get very much Twitter data this way. But if there's a specific set of users that you want to study, this is kind of the only way to do it. So it's worth knowing about. If you want to get the documentation on the REST API, you can go here. I'm not going to browse at will. What I'm going to use this nice little console that Twitter provides that allows us to make some queries to this, and you can see the responses, which I think can be useful. So let me open... So anybody can access this console. So you can do this too. We're going to be making calls to the api.twitter.com/1.1 is basically where all the REST API calls start. And you'll see exactly what that means in a moment. But it's basically version 1.1. I have no authentications, I need authentications, so I'm going to use OAuth 1. Sign up to Twitter. That's not encouraging. All right, 1 second. So what do I tell you? Access the internet. Everything goes haywire. Let me get myself logged in here. We'll use a different web browser. I think a cache may be causing problems. Any questions while I'm pulling this up? All right, now we're set. Okay, so you see I've changed my authentication to Derek Ruiz, my account. And now it's basically allowing us to call various make various API calls. Now, by the way, this is just an example. This is definitely not how you would do this as a full research pipeline, because we're literally going to have to type in stuff for every call that we want to make. That's not tractable. But suppose, for example, we want to go and get all the followers all the followers of some person's accounts. So what I've selected is the follower's call. So what you'll notice is this is just a web call, but it's not going to return a web page. It's going to return JSON data. So it's not enough to just call followers IDs. We need to say who we're going to get the information for. So let's get Lady Gaga's followers. So screen name, we have to enter that. She doesn't mind. All right, and so now we have this query, and what these things are, what's happening here is this request, that information is going to be tacked on to the end of this. Question mark, screen name equals Lady Gaga. We'll see that down here. So I'm going to submit the request. So you can see this is the actual query that was run. And here is what we get back. So there's the header. And this is the actual content of the call. There's the actual content of the call. It starts right here. So you see it's a JSON dictionary. Key is IDs, colon, and then what do we have? We've got a list. And that list is a list of all the user IDs that are followers of Twitter, of Lady Gaga. So you can imagine how you might write a script if you wanted to study all the language usage of followers of Lady Gaga. You would go grab this, you make this call, you get this long list, and then you would make other REST API calls. You'd say, oh, well, let me go get all the tweets generated by 119877184. Then let me go get all the tweets from 3432. Now, how do you do that? Well, we grab this, and then we go call a different REST API. We'll call it in a moment. I want to show you something that's important when dealing with these kinds of lists, though. Anybody know offhand how many followers Lady Gaga has? Several hundred million, probably. More than me. So, this did not return all of her followers. This returned the first 1,000. If you wanted to get the next 1,000, you need to make another call. And you'd have to use this cursor number in order to make the call. And I'll explain, well, I think I have it right here. Let me explain why we have to do this. Okay, so suppose we're just getting that follower list from Lady Gaga. So what we really, so many tweets. Pretend these are followers. We're getting some number of things. It applies to tweets too. People generate thousands and thousands of tweets. They're not all returned at the same time. But like we're asking for followers. We get 1,000 followers. We want more followers. So there's this idea of pagination, which was the original way that Twitter worked. And it seems like the most intuitive way to do it. Just give me the page number of all of these. Just separate them into pages, and then I will just go and I will query for the first page, then the second page, then the third page, and each page will give me a bunch of these. I'll get the next, then I'll get the next, then I'll get the next. But there's a problem with paging, and that is, what if between the time you call and you call again, there's new stuff added? If there's new stuff added, then what happens is you're getting duplicates, because this stuff gets pushed down, and all of a sudden, some of what you had gotten here is now down here in your next query. So paging, it's out. We don't like paging. The replacement for it is cursors, which is effectively a max ID. So you're giving index, the ID of the next tweet or the next follower that you actually want, and it's ordered in some way. So that makes sure that you don't get duplicates as you're querying for things. So when we look at this, if we queried with this next cursor, if we pop this down, you can see that some of the things available to us is cursor. We put that in there. That would end up being just another argument, ampersand cursor equals that number. we get the next set of followers. Okay, but suppose we wanted to get the tweets belonging to that particular user. Fingers crossed that this is actually a user of the public, whose account is public. We'll go up here, and we look for tweets. We want to show all the statuses of some particular user. So there's another REST API. So there's this. Let's see what happens. Send it. Looks like it worked. We got there. Oh, interesting. Well, we picked a good one. I think put Lady Gaga. I don't think it's going to like it. Let's see. No. Maybe user ID. Well, wait, we got a REST API. We can do that. So let's go get user. Information. Whatever. Right. Anyway, you get the idea. We're going to see a lot of data where that's concerned in a minute. So what is the kind of information that we can get when we make a call to a REST API? Well, of course, this is going to be very related to the kind of data that we're going to get from any call to an API streaming or otherwise. We're going to get a whole bunch of user profile data. So, for instance, we get when the account was created, we get a description of the account. That's the little text blurb that they write out themselves. They can put in a location field. This is almost always wrong. People use it for other purposes. So, some people will actually put down like where their location is. Other people will put things like the moon or like Justin Bieber's bedroom or like other things. So we can't really trust it. We have a number of followers and friends. Important to realize all of this is only valid at the moment that you call it. So you can't just go call it and then do a study in 2 months' time and have all of this be relevant or current. So in general, collect your data when you're going to use it. Whether or not their account is protected. If their account is protected, you can't get their tweets. Language. So this is the language of their locale. This is the language that they see the Twitter page in. This is somewhat useful for the purposes of language classification, but it's not great. And the reason is because in many places, there are various reasons why people would use language locales other than the language that they predominantly speak. A classic example is India, where there's actually social pressure to have an English page, because English is perceived to be sort of like a status symbol. And so if you have your Twitter and your Facebook account present in English, then it's sort of a social status indicator. The issue is that they may not be tweeting or using Facebook in English. They're still using their local language, but the locale doesn't end up being an informative indicator of language. So you have to be careful when using this. Time zone is a time zone the person. Is a time zone the person it's their resides in or has themselves registered in, and then number of tweets generated. So I'll give you some basic statistics. And then we get to actual tweet metadata. So we've already seen a bit of this, but it's worth pointing out some of the important characteristics that we're going to dig into. The first is text. So we've looked at that. Right? So we pulled out, we did a little exercise where we pulled out the actual text of some tweets. creation time, when this tweet was written, the platform, I should be going through this, the platform that it was generated on. Actually, before we skip too far ahead, let's do a little bit more with the text. So I want to go back to the command line. So just to give a sense for what's possible. So here we have, we've already seen that we have a bunch of tweets, and we can pull out their text content. Now, there's another helpful command we can use called mirror that basically lets us slowly walk through the content page by page. Oops. So I'm going to hit mirror, and so now we're just going to be going through this. Sort of one bit at a time. Now, immediately we notice some things. Notice that this tweet is the same as this tweet. And in particular, it's not just that it's the same tweet, it's a retweet of this particular tweet. So we don't really want that. So let's go get rid of retweets. Q to get out of more. So what can we do to actually get rid of retweets? Again, this is going to be sort of demonstrating more of the power of the command line. So one way you could do this is you could write some kind of program that would go through, that would look for that RT, and then would remove them, and then would print out the other ones. Well, in Unix, that command already exists. It's called grep. And all we're going to do is we're going to look for all the tweets that start with RT. That's what that says. Now that's the opposite of what we want, just to show that that's what grep does. So we're taking all this content that we generated using this jQuery command, and we're piping it into grep. So grep is now going to take every single one of those, and each line it's going to look at and say, if this matches this string, and by the way, this is a regular expression. If you have not learned regular expressions, go learn them. They are one of the most powerful text processing tools you can know. You never look at text the same way, and there's no alternative. If you want to work with text, there's nothing other than regular expressions that will get you the power that regular expressions can do. Suffice to say, how many of you have seen regular expressions? So regular expressions are ways of compactly speaking about classes of text. Now we're going to see some of them. So for instance, what this says, this is unfortunate, this is on the side of the screen, let me delete this a little bit. So that regular expression says that caret is the beginning of the line, and RT basically says right after the beginning of the line, there's the letter R and the letter T. So this pattern is called a regular expression pattern. This pattern is going to match anything, any string that I give it, any line that it sees that starts and then has R and then T. That's what it does. But just imagine how hard it would have been to write that otherwise without a regular expression. I literally captured that idea in 3 characters. It's difficult to get more powerful than regular expressions. Okay, so we just proved to ourselves that this is going to catch all the retweets. Well, retweet, it's all these retweets, right? RT, retweets. But that's not what we wanted. We want to get rid of them. Well, grep conveniently has a flag for inverting the match. -v says, print out anything that doesn't match what I just gave it. That doesn't match this regular expression here. So again, -v is not taking this as an argument. -v is just saying, whatever you're going to do, grep, do the opposite. So now, if we print this out, we see nothing that has RT at the front of it. Now at this point, we're pretty interested in what we've got. And frankly, usually at this point, I start to get worried because I think, well, how much data have I lost? So in order to do that, we can find that out very quickly. Let's look at our whole data set, retweets, not retweets, all of our data. We look at how many tweets we have. WC is word count, and -L is a flag that says, actually don't count words, count lines. So every one of these lines would be counted as one thing, and this is just going to print out the number of things that it gets. And again, I'm not putting in a file, because instead it's going to look at what's being piped into it. So this is producing some content, gets piped in there. All right, so we've got 2,227 tweets. Now let's remove all of the retweets. So here we're grepping, we've agreed that this is removing our retweets. So what am I going to write in order to actually count the number of tweets that I've got left? So I'm going to need a pipe. And then what's our counting command? Word count, WC. And then we want to count lines. What is that? I think we have 883. So by removing retweets, we've already lost over half of our data set. That is very common. And of course, we're not going to publish this result at the end of this talk, so we'll live with it. But the important thing is that, actually, I can see this over here. That's 883. But the important thing is, we've already done a whole bunch of analysis. We've already taken out retweets, looked at how many retweets there are in this thing, established sort of what our data set looks like, and what did we have to do? We had to type basically 3 commands. So the Unix command line is a very powerful place to work. So, okay, well, let's just continue with this. So let's say, all right, so we're looking at all these retweets, all these things around retweets, but look at this, we've got all these sort of white spaces, which we'd like to take out, because those certainly shouldn't count. So let's remove those. -V. So first we're going to look for all the things that are white spaces. Well, what is it? What is a white space? What does one of those lines look like? It starts. It has only space in it. And then it ends. That is, what this literally says is the start of the string has many spaces as are necessary, so match 0 spaces, 1 spaces, 2 spaces, tabs, whatever, and then end of the string. So this is basically permitting no other character except for space to exist. So let's make sure that this is what we're matching. Yeah, there's a lot of white space. So now we'll just invert that. Now our white space is gone. So of course, now the question is, how many tweets do we have? So we've lost about 40 tweets. Okay, so in any case, this is how you can work on the command line quite powerfully with Twitter data and with any other data that you obtain. Of course, you're not going to do most of your analysis on the screen and then forget about it. You need to store this somewhere. So what you can do is you can route, this is called redirection. You can redirect, so a pipe puts something into a new command. This redirection error pushes something into a file. So I'll just push that into this. And then tweet_text. Well, if we look at tweet_text, well, it just contains all the tweets that we are pulling out. So now we can take that, if we formatted this in a particular way, we could push that into R, we could load this up into Python, we could do various things with this. Any questions? Okay. Yes?
For real research, which API should I use? The free version or I need a subscription?
The subscription or free?
Yeah. What do I need? What do I use?
For Twitter, for real research, you can, it depends upon the research question. I think the key question to ask yourself is, what is the data that I need? I would say, in general, you can use the stuff that's available for free. You have to have a Twitter account. You have to create a Twitter account, and that gives you access to the REST API and the streaming API. I would argue that the streaming API, whenever possible, is going to be your best bet because it's going to give you this continuous dump of content that's not really bounded in the same way. The REST API, for reasons we'll discuss in a moment, is limited. You can only make a certain number of calls per hour. And so if you wanted to, I don't know, for instance, look at all Twitter users, you literally couldn't do it using REST API. I mean, you'd run out of calls. You'd probably have, I don't think you could ever do it, actually. It would be impossible. And so your best bet would be use the streaming API to get a sample of all the Twitter users you want to look at. Now, sample, that brings up a very important point. I'm not going to talk about it a whole lot, but I think that it raises the very important sort of contributions that statistics makes to this work, which is there's always sampling going on. And so, when performing a research project, it's really important to think about what kind of sample you're getting and being principled about that. And of course, statistics is the discipline that tells us what kind of samples we should be taking, when we're safe, when we're not, when we can actually trust our hypotheses. And so, I mean, there's no cut and dry answer to the question of what should you use, but in designing it, I mean, it's very rare for a researcher to have to use something that's not free. So from that standpoint, I think that free is fine, and I would say use the streaming API whenever possible. Yes? Oh, sure.
Of your talk, you were saying that this research in social media complements the surveys that the traditional surveys. So what are your thoughts? For example, we have here in our bachelor's degree some courses in surveys. So would you recommend to incorporate some of these issues in a survey course like that?
I think that, so this is unexplored territory. To my knowledge, there are not a lot of people currently thinking about how to integrate social media analytics into survey design, despite the fact that it's being done in various places. So yes, I would highly recommend that. I think that one of the things to keep in mind is that as you're seeing, doing this kind of analysis is non-trivial, and it involves a great deal of work. So if, the ideal world would be that you'd have complementary courses where people would take the sort of Twitter data mining, social media data mining course, and then they would take a survey course. And in the survey course, they would already have the background for being able to do sort of some fundamental analysis that they could then really understand how to use this to inform survey design. But even without that, I think that it would absolutely be worth integrating, having a section of that course where you would talk about where you can get alternative sources of data that inform good survey design.
Yeah, I think so, especially for the students who are young and they use Twitter and Facebook and everything, So you have all these millions of information and they are using and then they are studying the traditional survey. It's kind of surreal, because there is so much information over there, but they don't have the tools to get it.
Yeah, absolutely. So no, I think they're very complementary, and I think that a curriculum that did that would be pretty cutting edge too. I mean, I've not seen very many curricula that actually sort of try to integrate these, but I think that it is an important direction for us to be thinking about. So.
Okay, thank you.
Yes.
Por favor, es que
How can you deal with emojis in the tweets?
Emojis?
Yes.
Well, I mean, some people love the emojis in the tweets because they actually encode sentiment of some sort.
But I try to download my WhatsApp text and I get only symbols and all those were emojis. So how can you make those to appear in you to interpret? That's what emoji.
Yeah, so there's a couple ways of doing this. I mean, emojis, there's a number of online resources that have long listings of the emoji sequences, and you'll never catch all of them. But I would venture to say that you could probably cover 95+% of them by actually integrating online databases of emoji characters. And these differ culturally, right? So the Japanese have like very rich emoji sets because they typically use Unicode. But in any case, what I would say is you would code what each emoji means within the context of your study. So one of the classic things that's done is they're used as a way of measuring sentiment. Or is this tweet happy or is it sad? And so you could use it, and so then the question would be, you pull the emoji, but it's not enough to just pull the emoji. You have to pull the emoji and actually be able to say, is this a happy emoji or a sad emoji? And so then what you do is you create a lookup, a new file that would basically you go through, or you or a student or somebody would go through and code the valence, the sentiment of each emoji. And then what you could do is in the tweets, when you found an emoji, you could then label the tweet as being either happy or sad. Now, of course, that's just one example. I mean, there are many other uses for emojis, so it would depend upon your particular question, but that gives you an example of the kind of analysis that you could do. The unfortunate reality is that when you start digging into emojis or these kinds of sequences, there is often a lot of manual effort that goes into coding this stuff. Yes?
I was wondering about the Justin Bieber example, because even if there is some people making this like a joke, maybe there are some others that really think they wish Justin Bieber for Christmas. I mean, and it's not that they're going to get it, but to get him, but maybe you can make some posters. How do you handle this kind of data? Because you cannot dismiss it because it looks really weird. You have to take them into account because they're important. But always know that there are some people that are not answering this seriously.
Yeah. I think there are a couple ways of approaching this. Fundamentally, though, what I find very useful is sharpening the question that I'm asking, so I can either include or exclude those tweets. So for example, in that analysis, we did the analysis, Justin Bieber came up as the top hit, I became depressed about the state of humanity, and then after I recovered, what I did is I said, all right, so we clearly have tweets that are about non-tangible things and tangible things. And so I kind of all along the lines of that, you get to your analysis step, and then you look at your data, and then you say, oh no, what have I got here? We took a loop back, and we said, all right, we're refining our question. Our question is now, how are people wishing for tangible things? And of course, I wouldn't have known when I first came up with my question, I wouldn't have known to explicitly say tangible things. But by inserting that into my question, it permitted me to ignore that data or set that data aside without, while still privileging it as meaningful data. Like, it's just that I made it non-relevant to the question I wanted to ask. For instance, I think that sociologists would probably be very interested in the fact that people are wishing for Justin Bieber, for jobs, for boyfriends and girlfriends. Like, they are telling us something. They're telling us something. But we need to be careful about how we frame our question. And I think that handling this kind of data, many people think about it in terms of, well, let me figure out how to classify this and all this. I think it starts by figuring out how to fit your question, how to reframe your question so you get exactly the data you want. Yes, I
was wondering, this kind of research is only for Twitter, because the structure that you say is only in Twitter. The things with tweets and
the JSON format and things like that.
Yeah, exactly. So I was wondering if, Facebook, Instagram, if you can make this research for that type of social networks.
Only Twitter? Only Twitter? No. You're right. So this, what I've been showing you is Twitter. However, everything that I've shown you in terms of JSON, so JSON has become the reigning standard for data delivery in APIs. So if you go and query Facebook APIs, it's JSON. If you go and query Reddit APIs, it's JSON. If you go and query, I'm trying to think, I can't remember the last time I encountered social media data through an API that was not JSON. So actually, everything that I'm showing you, it's true, the streaming versus the REST API, that's kind of specialized to Twitter. But the broader notion of obtaining data in this JSON form and then working with it and manipulating it, it's universal. It's universal. So all the commands I've been showing, everything like that, it's all standard. You could use this on anything. I'm getting a, yes? Yes. Can I take one more question? And then? One more. Okay.
How do you handle the pictures in Twitter? Like, do you depend on the hashtag, or do we have to make an individual analysis of each picture?
Yeah, that's a very important point, because a lot of information ends up being coded in images. And Twitter is one thing. Pinterest or Instagram is even harder because it's all images. So classifying images using computational methods is very iffy. It doesn't always work. In fact, it often doesn't work. What I found to be very useful is to use crowdsourcing methods. So to use Amazon Mechanical Turk or Crowdflower. You can toss thousands of images up, and you can get them labeled in hours. You can get tens of thousands of images labeled in hours. But there you really need to know the question that you're asking. If there's time at the end of the talk, I'll talk a little bit about crowdsourcing, because it's very relevant to this kind of investigation. Okay, so I've got an indication that we're going to take a break, and then we'll come back.
Yeah, and after the break, you can also, after the break, can ask more questions.
Yeah,
Okay?
absolutely. All right, thanks.